Chapter 6, Lesson 5 of Advanced Algebra, and we want to look at some examples where we are given the zeros of a polynomial and we're asked to then write the polynomial that has these zeros in standard form. And a few reminders of things we want to be sure that we take care of. When we're given the zeros, we know we need to put them in their factored form, so it's going to be x minus, and then we're going to be put the 0 right in here. That's going to give me my linear factor. I'm then going to multiply all these factors together to get the polynomial in standard form. The second thing there's to remember is that the imaginaries always come in conjugate pairs, so we'll always need to remember to write the second one if it's not given to us. The irrationals always come in conjugate pairs. And then we should always remember that when we get to the end of our final answer, that imaginary and that square root should be gone. We shouldn't have that in our final answer. If we do, we've done something wrong. Now, one tip that you want to do or remember as you're going through this is that when you go to multiply these factors together, and you're going to usually have more than 2, you can multiply any 2 together that you want, and then you take that answer and multiply it by the next one, etc. In order to make it easier is you'll want to multiply the conjugates together first, because when you multiply the conjugates together, that square root is going to go away, or that imaginary number is going to go away in that step. So if you eliminate it first, then if you have to multiply again by another 0, you don't have those imaginaries and square roots to mess with, and it can get kind of messy. So remember those things, and then we'll go from there. So let's go ahead and tackle this first one here. Now, they give me the square root of 3 as a 0, the square root of 2, and negative square root of 2. I notice that these two are conjugates, so those are taken care of. But the square root of 3, I have to remember that if the square root of 3 is a 0, so is negative square root of 3. So this is a case where I have to remember that for myself. If I don't, I'm going to end up with a square root at the end, and obviously that's not going to be correct. So now that I have the zeros, I'll go ahead and put them in their factor form or linear form. So this is going to be x minus this 0 of square root of 3, and then I should write the conjugate next. So x minus its conjugate, that's negative, so that's going to make this positive. And then I'm going to do the next one, x minus the square root of 2, and then x minus its conjugate, which makes that positive square root of 2. Now, I can only multiply 2 together at a time, so I'm going to multiply the first 2 conjugates together and then move from there. So I'm going to kind of do this distributive property and write out what the process is in the first few, and then as we move forward, I'll skip some of those steps and start doing it a little bit quicker, but just so you see how this works. Again, this is simply the distributive property, so I need to take this x and I multiply it by both of these. And then I take this negative square root of 3, whoops, that's not a parentheses there, this negative square root of 3 and multiply it by this x plus square root of 3. And then I still have this x minus square root of 2 and this x plus square root of 2 that I'm not doing anything with in this step. So I'm going to go ahead and distribute this now. So this is x squared plus x times the square root of 3, and then this is negative x times the square root of 3, and now this negative times a positive is going to be a negative, and this square root of 3 times square root of 3 is going to be 3, and again, that's where my square root goes away, and then I still have this x square root of 2 and x square root of 2 over here. So now I can combine like terms, and you'll see these are opposites, so it's going to be 0. So those two multiplied together ends up being x squared minus 3. Now again, I can multiply these next two in any order that I like, but I want to use the conjugates, because if I multiply this x squared minus 3 times this square root of 2, that square root of 2 is not going to go away until the next step. So I can, by multiplying the conjugates, I can take care of that in one step, and then I won't have to worry about that mess. So I'm going to keep this x squared minus 3, and then I'm going to distribute these two. So I'm going to take this x and multiply it times this x plus square root of 2. And then I'm going to take this negative square root of 2 and multiply it times this x plus square root of 2. Alright, so I still have this x squared minus 3, whoops, x squared minus 3. And then I have this x times that, that's x squared. And then this x times that is x square root of 2. and then this is negative x square root of 2, and then this is a negative times a positive, negative, and a square root of 2 times square root of 2 is 2. Again, you'll see the square root goes away. So x squared minus 3, and then these two are opposites, so those go away, so I'm left with x squared minus 2. So you can see by multiplying the conjugates together, I take care of those square roots in the early part, and now I'm just left with this at the end. So I multiplied these two together and get an answer. I multiplied these two together, get an answer. Now I still have to multiply these two. So again, I'm going to distribute. So I'm going to take this x squared times this x squared minus 2, and then this negative 3 times this x squared minus 2. And so that's going to give me, I'm going to go over this way here, x squared times x squared is x to the 4th, and x squared times negative 2 is negative 2x squared, and then negative 3x squared, and then negative 3 times negative 2 is positive 6. So combining like terms, then I have x to the 4th minus 5x squared plus 6. Plus 6 is the polynomial then that has these as its 0, and this is the polynomial in standard form. Okay, so that kind of encompassed everything that we needed to do and everything that we need to remember. Remember that the conjugates, the irrationals come in pairs, the imaginaries come in pairs, and then you want to multiply those conjugates together first to get rid of those square roots and imaginary numbers, and then you just have a simple distributive property problem moving forward. All right, let's take a look at number 2 because it has something interesting going on with a multiplicity of 2. Again, as we look at this, we see that negative I is a 0, so we also, it says that it has a multiplicity of 2. So if you remember, what does that mean? That means negative I is used twice. So not only is negative I a 0, it's used twice. Now again, every imaginary number that is a 0, its conjugate is also a 0. So not only is negative I, this negative I a 0, so is its conjugate positive I. And not only is this negative I a 0, so is its conjugate positive I. So I actually have 4 zeros here. All right, so I'm going to go ahead and put these in their linear form, or their linear factor form. So x minus the 0 negative I, so that's going to be plus I. And then x minus its conjugate I. And then the second one, its multiplicity, x plus 1. And then its conjugate, x minus I, is also. So again, I have 4 zeros here, so I'm going to go ahead and multiply the conjugates together because that's going to get rid of the i's to begin with. Now I'm going to take a shortcut here. I recognize that conjugates are always going to, the middle terms always going to go away. So I don't really need to worry about the middle term. And all I need then is the last term and the first term. And the last term is simply going to be the first term squared, so x squared. And then the last term, it's always going to be minus. And then the last term is going to be these two multiplied together. So I times I is I squared. But what is I squared? I squared is negative 1. And then minus a negative 1, so this is actually going to be x squared plus 1 is what I get when I multiply those together. Now, these two are identical, so I'm going to get the same thing again, so I don't need to multiply that out again. So again, by multiplying the conjugates together, that I goes away, and now in my last step, I don't have to worry about those. So again, I'm going to use the distributive property, so I'm going to take this x squared times this, and then I'm going to take this positive 1 times this, and simply distribute. So x to the 4th plus x squared plus 1. So x to the 4th, x squared plus x squared is 2x squared plus 1. So this would be the polynomial in standard form that has these as its 0. Okay? All right, I'm going to do, again, a number of examples. Hopefully that kind of gives the foundation for everything that we're going to do beyond this. So if you think you've got it, you can stop after that. If not, these are kind of the easy ones. I will do some more difficult ones later on, so if you want to check those out, you can just kind of fast forward and take a look at one that looks challenging to you. So for number 3, we'll go ahead and do this one because this combines two things. First of all, we have an irrational root, and so we know that the conjugate must also be a root. So if negative 3 plus the square root of this is a root, then negative 3 minus square root of 7 is also a root. And again, this has a multiplicity of 2, so that means this negative 3 plus the square root of 7 is used twice. So negative 3 plus square root of 7 is used twice. That means its conjugate, negative 3 minus square root of 7, is also used twice. Okay, so we have the 4 zeros, so now again we want to put them in their linear factors. So remember now, this gets kind of a little bit crazy. It's x minus, and then it's this whole thing. So minus a negative 3 would be plus 3, and then minus this plus square root of 7 ends up being negative square root of 7. And then x minus, and then again that negative 3 becomes a positive, and then its conjugate is also a 0. So this is again x minus, and we put the 0 in here to get our linear factors. And when we put in this negative sign applies to both. So I have to change the sign of this and the sign of this for my first one. And then for this conjugate, I need to change the sign of this and the sign of this for my second one. So basically, it ends up flipping that conjugate, but basically we end up with this. All right, so again, both of these are used twice, so I get x plus 3 minus 7, square root of 7 used again, and then also x plus 3 plus the square root of 7 also gets used again. So I have my 4 factors here, and now again, this is why we wanted to do the distributive property, because again, I have a trinomial now type of expression multiplied by another trinomial. FOIL doesn't work, so I'm going to use distributive property. And again, I'm going to multiply these two conjugates together first, because if I do that, the square roots should go away. And also, it's nice that it's a multiplicity of 2. If I do this once, this one's going to be the same, so I really only have to do this once. All right, so we're going to take this x, and we're going to distribute it to this whole thing. So it's going to be plus, or times x plus 3 plus the square root of 7. And then I'm going to take this positive 3, and I have to multiply it by this whole thing, x plus 3 plus square root of 7. And then I have to take this negative square root of 7, and I have to multiply it by this whole thing again, x plus 3 plus the square root of 7. So we're simply, again, doing the distributive property. All right, so now again, we'll distribute this and then combine like terms. So the x times the x is x squared, x times 3 is 3x, and then x times square root of 7 is just x square root of 7. And then I have a positive 3 times x, so that's plus 3x, and a positive 3 times positive 3 is a 9, and then a positive 3 times the square root of 7 is positive 3 square root of 7. And then I multiply this negative square root of 7 times x, so that's going to leave me negative x square root of 7. Whoops, square root of 7, not x. Let me get that right. Sorry. And then negative 7 times this is negative 3 square root of 7. And then this negative times this positive here is going to be negative, and square root of 7 times square root of 7 is 7. All right, so now that I have all that, I simply combine my like terms. So I have an x squared here. So that takes care of that. I have a 3x here and a 3x here, and that's the only x term, so that's a plus 6x, so that takes care of those. Now again, if we've done this right, the square roots should go away. So when I see x plus square root of 7, I should have a negative x square root of 7 that adds up to 0, which cancels those out. So I have it here and here, so that takes care of that. Here's a positive 3 square root of 7. Here's a negative 3 square root of 7. So that's 0. So those go away. So then I'm just left with this constant 9 minus this constant 7. So that would be plus 2. So that takes care of everything. So you can see when I multiplied the conjugate, all the square roots went away. Okay? If I multiply conjugates and I get here and I still have square roots, I know I've done something wrong. I need to go back and check my arithmetic. Now the nice thing about having this as a multiplicity of 2 is I now know what these are going to be when I go to multiply those together. I'm going to get the exact same thing. So when I multiply these two conjugates together, that's going to give me x squared plus 6x plus 2. And now I have this trinomial times this, so I just use the distributive property again to come up with my answer. So I'm going to take this x squared and I'm going to multiply it by every term here. X squared plus 6x plus 2. And then I'm going to take a positive 6x, let me put that there, and I need to multiply it times this whole trinomial. And then I need to take this positive 2, and multiply it times this whole trinomial. X squared plus 6x plus 2. All right? Then I just need to be careful and do my arithmetic. So this x squared times x squared is x to the 4th. X squared plus or times 6x is going to give me 6x cubed, and then x squared times 2 is 2x squared. 6x times x squared is 6x cubed. 6x times 6x is 36x squared, and then 6x times that 2 is 12x. And then 2 times x squared is 2x squared. 2 times 6x is 12x, and then 2 times 2 is 4. So I've done all my distributing. I just have to find my like terms now. So I have an x to the 4th to begin with. Here's an x cubed, here's an x cubed, and that's it. So I have 6x cubed and 6x cubed, so that's 12x cubed. So that's correct. And then I have an x squared here, an x squared here, and an x squared here. So I've got 2x squared plus 36 plus 2, so that's 40x squared. So that takes care of all my x squared. And then I have a 12x and a 12x, so that's 24x. And then I have a constant of 4 at the end. So this would be the polynomial in standard form given this one irrational root. And again, I have 4 factors because I know that irrationals come in pairs, and I know this has a multiplicity of 2. Okay, we'll do a couple more examples. I'm going to do one kind of easy one, but because it has a 0, I just kind of want to have you take a look at that one. So I'm given this positive square root of 7, so the irrational root theorem says that its conjugate must also be a 0. So I have these 3 zeros. So again, I'm going to put these in their linear form. So this one would be x minus, and then I put in the 0, which is x. And then I have x minus this one, which is the square root of 7. And then I have x minus this root, which is a negative, so that makes this positive square root of 7. Now this is x minus 0, which is simply x, so I can simplify that. And if I recognize that at the beginning, I don't need to go through this step, but I wanted to show you where that comes from. So now again, I could distribute this in here, but I'd rather multiply the conjugates together first, take care of those square roots, and then I don't forget I do have to multiply it by x. So I'm going to distribute, but again I'm going to take the shortcut here. I know that this is going to be a difference of 2 squares, so I know it's going to be a minus sign. So I simply square this, x squared, and then I square square root of 7, which is simply 7, and there's my answer. Now I can distribute this, so that's going to be x cubed minus 7x. This would again be the polynomial given those zeros. Okay, we're going to do number 8 here and wrap this up. I think with number 8, that one kind of looks complicated. It's about as complicated as we'll get. So we'll do number 8 and then we'll wrap this up. All right, again, we have a couple things going on here. We have a multiplicity of 2 for this one, and we have a multiplicity of 2 for this one. Now this is interesting because these are conjugates of each other. So this is 2 plus 2i and 2 minus 2i. So does that mean I have 4 of them, or does that mean I just have 2 of them? That's a very good question. And really, it answers itself. If I have these 2 plus 2i with a multiplicity of 2 used twice, I know that these 2 are conjugates. If these 2 are conjugates, then I'm already using these twice. So actually, this is kind of a tricky way of actually giving me all 4. So my the conjugate of this is a 0. which I have, and then the conjugate of the second one is a 0 is also what I have. So I'm going to have 2 of these, and I'm going to have 2 of these, and those are going to be my factors, and then we'll just multiply them together. So again, it's x minus, and then again it's minus this whole thing. So I take the opposite of the 2, and I take the opposite of the 2i. That's 1. And its conjugate, x minus, again I take the opposite of this 2, and I take the opposite of that, so that's going to be plus 2i. So that's 1, 0 imaginary and its conjugate. And then again, because it's a multiplicity of 2, I'm going to have 2 of these, or 2 of each of them. Okay, so now that I have those, again, it's nice that these are the same because I'll just need to multiply these conjugates here, and then when I multiply those are going to be the same. So we're going to use the distributive property. So I'm going to take this x times this whole value here, this polynomial here, so this x minus 2 plus 2i, and then I'm going to take this negative 2 and multiply it times this whole trinomial. And then I'm going to take this negative 2i and multiply it by this trinomial. So again, we're just doing the distributive property with all 3 values. All right, so we'll distribute this. So now I have x squared. X times negative 2 is negative 2x, and x times 2i is simply 2xi, or 2ix, however you'd like to write it. Now, negative 2 times x is, negative 2x. Negative 2 times negative 2 is positive 4, and then negative 2 times this is negative 4i. Now we distribute the negative 2i, so the negative 2i times x is negative 2xi. The negative 2 times this negative 2 is positive 4i. Now here's where we have to be a little bit careful, because we have this negative 2 times this positive 2, which is negative 4, but we have the I times the I, which is I squared. But remember, we should remember that I squared actually means negative 1, and then this negative 4 times that negative 1 actually changes the sign of that 4 to a positive. So be careful with that when you're doing that I squared. Now we combine like terms. So I have my x squared. I have a negative 2x here and a negative 2x here, so that's going to be negative 4x. Okay, now the i's should go away, so positive 2xi, negative 2xi's, that does add up to 0. And then this negative 4i, the positive 4i, that does add up to 0. And so then I have 4 plus 4, which is 8. And you'll notice, because I multiplied conjugates, those i's have gone away. And again, that should always happen. If it doesn't, we know we've done something wrong. Now again, the nice thing about this is these two are exactly the same, so I know when I multiply them together, I'm going to get this same trinomial, x squared minus 4x plus 8. So I've taken care of all the i's, so now I just multiply these together and I get my polynomial. And again, it's simply the distributive property. So I'm going to take this x squared and multiply it times this whole trinomial, 4 plus 8, and then I'm going to take negative 4x, and I'll multiply it by this trinomial, squared minus 4x plus 8, and then I'm going to take this positive 8 and multiply it by this trinomial, x squared minus 4x plus 8. And then we will just distribute this out. So x squared times x squared is x to the 4th. X squared times negative 4x is negative 4x cubed. We add the exponents. X squared times 8 is 8x squared. Negative 4 times x, or negative 4x times x squared is negative 4x cubed. Add the exponents. Negative times negative is a positive 16, and then x times x is x squared. Add the exponents. Negative 4x times 8 is a negative 32x. And then I have a positive 8 times x squared is positive 8x squared. 8 times negative 4 is negative 32x. And then 8 times 8 is 64. So I've done all my distributing. Now I simply combine like terms. So I have x to the 4th. So it takes care of that. I have an x cubed here, an x cubed here, and that's all I have. So negative 4x cubed and negative 4x cubed is negative 8 x cubed. So that takes care of those. I have an x squared here, an x squared here, and an x squared here. So I have 8 plus 8, which is 16, and then plus another 16, so that's plus 32x squared. Takes care of all my x squared, excuse me. I have a negative 32x and a negative 32x, which is negative 64x. Takes care of those. And then I have a constant 64 at the end. So this would be the polynomial in standard form that has these as its zero. Okay, so I'll wrap things up in just 4 or 5 reminders. Remember that irrational zeros come in pairs. Imaginary zeros always come in pairs. Remember, multiplicity simply means you use that zero twice. Once we know the zeros, we put them in their factored form by doing x minus and then putting in the 0. And then it's simply distributing those values or multiplying those linear factors or those factors together. And then remember, when you multiply the conjugates, you'll want to do that first. The i's should go away. Any i's do you have? And if you're multiplying irrational conjugates, the square roots should go away. Your final answer should never end up with any square roots in it and any i's in it for what we're working with right now. Okay? So hopefully that was helpful to you. Watch these videos as many times as you need. And we've got one more lesson that we'll do, or one more video that we'll work on combining all of these things together in solving these polynomial equations or determining all the roots of a polynomial equation.